So just to recap a little bit, like I said, I'm not going to do this entire thing because you do have a little bit of knowledge of it already. But I want to make sure that everybody understands how to find the area of a segment of a circle. And a segment of a circle is when you have a sector partitioned off by a chord, and it's just that little part right there. That's a segment of a circle. So what we really need to understand is that to find that area, you need first the area of the entire sector, and then you subtract out the area of that triangle there, and it leaves you with that shaded region. So the first thing that's on this sheet here is the area of a triangle. Well, the area of a triangle is 1/2 base times height. You've learned that before, you've used it before. It works here, but it's not the best way to find the area of a triangle for this particular method that we're using. So there is another formula for the area of a triangle. The problem with this other area formula is that it only works when you know SAS situation, when you know two sides and the angle between those two sides. So in that situation, if you know the length of C and the length of B and the value of the measure of angle A, this formula will work. 1/2 the length of B times the length of C times the sine of whatever angle A is. So let's just do one of those here. Let's do B. Okay. Area. We know this angle, so we have an SAS situation, so we know we can use that formula. 1/2 times, what am I going to do? 6 times 5 times the sine of 140. So 1/2 of 30 is 15. So in our calculator, we can just do 15 sine 140. And what do you get? Area equals 9.64 to the nearest tenth. 9.6. Some of you guys have to pay attention to how you're rounding things. On your tests, there was a lot of people that didn't pay attention to that. Okay, so since it's area, it's square inches. Okay, pretty straightforward, right? So why is that better in the area of a segment situation? Well, that's better because when we have to find the area of this triangle, we're always going to know the degree measure of that angle because we need it to figure out the area of the sector anyway. We need to know how many degrees that arc is, so we have to know how many degrees that angle is. The length of the two sides, the B and the C in this case, are both radii. So as long as we know the radius, we just do the radius times itself, times 1/2 times the sine. So it becomes a really useful formula for this method here. Okay, so area of a shaded region. This is like in general. Remember we talked about, you've done shaded region before, like, you know, there's a swimming pool and there's a sidewalk around it, and what's the area of the sidewalk, right? Or there's a frame around a picture. You've done this before, right? What did you always do to find the shaded region? Yep. Yeah, you find the whole area of the big rectangle and you subtract out the area of the unshaded region. And it leaves you with the shaded region. Okay, so that's the same concept here. It's the area of the whole sector, subtract out the area of this triangle, and it leaves you with the area of the segment. That make sense? Okay. So Now, here's the trick of it. If they ask you to leave your answer in exact form, that's when it gets a little complicated, right? I am going to accept exact or decimal. So that makes the process a lot easier. If you can do it as a decimal, it makes it a lot easier. If I asked for it in exact form, could you use the 1/2 BC sine A? No, because anytime you use a sine or a cosine or tangent, whatever, it's always going to give you an answer as a decimal, and that is not exact form, right? So that's why exact form complicates this this method. For now, we're just going to do it as a decimal, okay? So we know the radius is 4. We know this angle is 90. We are going to need the area of the entire circle first. Because in order to find the area of the sector, remember, it's the fractional part of the whole area. So we need the area of the circle first. What is the area of the circle? Yep. Yes, 16 pi. So 4 squared pi, or 16 pi. And we can leave it as pi for now, right? Our final answer is going to be rounded. But let's leave it as exact as possible for as long as we can, right? So the area of the whole circle is 16 pi. Okay, so now we need area of the sector. Well, the area of the sector is the area of the whole circle times the fractional part, right? So we need 90 over 360 times the whole area, 16 pi. So that's 1/4 of 16 pi, which equals what? 1/4 of 16? 4 pi. Okay, so the area of the sector is 4 pi. That's the entire sector, right? Now we have to subtract out this triangle. So, next thing we need to do is find the area of that triangle. One half BC sine A is 1/2 4 times 4 times the sine of 90. So what's the sine of 90? Sine of 90 is 1. 4 times 4 is 16. And we have to take a half of that. So the area of the triangle is 8. So far, so good? Okay. So area of the segment then, let me change colors. Equals the area of the sector minus the area of the triangle. So we're going to do 4 pi minus 8. Now for this one, since the sine of 90 is 1, we didn't end up with a decimal, so if they asked for exact form, you could leave it in its exact form, right? The exact form would be 4 pi minus 8. Can you simplify that? No, it just would be 4 pi minus 8. But since the directions say to leave it to the nearest tenth, you're going to want to do 4 pi, so 4 times pi, and then subtract 8, and you get 4.5, what does it say, to the nearest tenth? So 4.6. It's 4.566, which is approximately 4.6. Now, that is meters, and since this is area, it's square meters. Yeah, so the whole area is 64 pi. Now, to get the area of the sector, this whole shaded part, the blue shaded, we need the area of the circle and the fractional part of it. Well, if this piece is 60, how many degrees is this one? So it's 120 out of 360 times 64 pi. And that's 1/3. So it's 1/3 of 64 pi, which doesn't come out to divide exactly evenly, so we're just going to leave it as 64 pi over 3 for now. That's the area of that whole shaded sector. In order to get just this yellow part, what do I have to do? Good. Area of the triangle has to get subtracted out. So now is when we do 1/2. What's the radius? 8, right? Because if the whole width is 16 here, right, then halfway across is 8. So 1/2, 8 times the sine of, what am I going to do here? 120, not 60, right? 1/2, 8 times 8, sine of 120. And that should come out to 27.71. So that's the area of the triangle. Now, to get this yellow shaded region, I do the area of the sector, 64 pi over 3, minus 27.71. And I'm going to get an approximate decimal to be 39.3. And it's inches, so it's square inches. Okay, so for this one, since both the radii are the same length, if this little angle's 45, then this angle has to be 45 as well, which makes our central angle 90, which makes our arc also 90. So the area of the triangle is 81 pi. The area of the sector is 1/4. 90 out of 360 is 1/4 of 81 pi. And the area of the triangle is 1/2, 9 times 9 times the sine of 90, which is 40.5. So this area of the segment is 81 pi over 4 minus 40.5, which is approximately 23.1 square feet.